Thank you. Hello, everyone. This is Bomin Lee from Constamp. I'm a security auditor. And the topic today I'm going to talk about is double spending in BSV. Is it possible? So firstly, I will briefly explain what is Bitcoin SV, so-called BSV. And secondly, I will talk about is double spending possible? What is double spending, and is double spending possible for BSV in its current condition? Thirdly, I will talk about how to implement exactly more details given how to do the double spending in BSV and what's the cost. But finally, I will talk about that another way to do double spending specifically in BSV only. First, what's BSV? In 2017, it's forked Bitcoin Cash. And the goal of the BSV team is to stick to the great original vision of Bitcoin. Try to make it the cash for everyone. I mean, literally for everyone. Everyone can use it as a cash, but not only like cryptocurrency as a trading target, trading pair to the hedging or speculation. The BSV's goal is to be the cash for everyone. So to achieve that, you need to be fast in reaching the settlement state. Just like nowadays, what the cash is, right? So they have to achieve this by enabling certain characteristics and certain technical characteristic, right? So the first one, I think the core concept of it is first is to increase the block size. The second one is to support the zero combination. That's what they claimed. So this is for BSV. In this slide, I'm going to explain briefly what is double spending. So first, in a normal trading scenario, there's a buyer and a seller, right? And there's a BSV blockchain. So all the balance changes depends on the transaction the buyer sent to the BSV blockchain to enable the transfer of the Bitcoin SV, right? And this is a trading scenario. When a buyer wants to purchase a product from the seller, first tell the seller that I'm going to purchase one good from you, okay? And then send a transaction to BSV blockchain. Let's call it transaction 1 or whatever. Send a 1 BSV to the seller. This is what this transaction do. And then the seller checked that the transaction is okay, is valid, and it's BSV balance of the seller's wallet +1. And then the seller feels safe, good, and then the seller will deliver the product to the buyer. So this sounds great, right? Seller earns money. However, the next step, the buyer ran away. Suddenly, he do something to revert the original transaction. We call that transaction 1, right? The transaction 1 was reverted, and the seller will find out the transaction 1 is reverted. So then the BSV balance will -1 because it no longer exists. And then the seller cannot get back the product, and the buyer has run away. So this is what double spending is. The seller lose money. The buyer is a hacker. So to explain how to do that in BSV, firstly, I will talk about what is POW insured, because it is related. First, for POW is the most commonly used algorithm for the public blockchain system nowadays. It's a consensus algorithms, and that includes BSV. BSV also use POW based consensus algorithm. And the concept of it, I'll just talk about the concept. The concept of this is that probability of a miner a chance to execute to include any transaction that they select is proportional to the computational power that the miners owns. This is the easiest way to understand this concept. And then we have a website called crypto51.app, which shows all the coins, all the famous coins, the symbol, the market cap, the algorithm that you're using, and the hash rate it currently have, which means the total hash power that you currently have on the network, and the 1 hour attack cost if you want to attack it using the 51% attack. Oh, I should explain what is the 51 attack cost here. So the probability of a miner to include transaction whatever it wants is based on it's proportional to its mining power, right? So 51% of hashing power means it has 51% of probability to be the miner that can include transactions, to be the miner to do to change the ledger, right? So 51 attack means an attacker having the hashing power for more than 51%, so that can do something malicious. And here's the hash rate that currently owned by different network here, different blockchain. So on the other hand, or on the other word, if you are a hacker and you have the hash rate more than 51%, for instance, for Bitcoin SV, you have more than 1,000 and 1,500 pega hash rate, and then you can do something malicious like double spending. And this is a 1 hour attacker cost if you want to spend it on the internet. I mean, drain the hash rate. So I'll talk about it later. So then the following I'm going to explain is the core concept of double spending using this 51% attack. What can really be done, and what is the underlying mechanism of it. So here I will take Bitcoin as an example. Okay, the first step, let us look at this blockchain. We have an original blockchain. It's a green one, like 38, block 39, block 40, 41, 42, right? And the first step, if you want to attack someone using the double spending attack, first step for you to do is to fork your own blockchain, private blockchain. If you be the miner, you be the miner. You be a miner and have a 51 more hash power more than 51%, right? So you fork your own private blockchain, and you do not broadcast. You don't broadcast, and you concave blockchain longer and longer. This is the first step. And then the second step is to spend the Bitcoin only on the original blockchain, only on this one, like 40. And then when you spend that Bitcoin, and your buyer, you are a buyer, right? And the seller they'll perceive that they have obtained 100 Bitcoin and provide you with goods. And then simultaneously, in the blockchain that you currently managed but not broadcasting, you just don't send that transaction. You exclude that transaction from the blockchain that you are maintaining. This is step 2. So when step 3, because you have the 51%, your hash power more than 51%, so you are faster than the others. You have higher probability to concate a longer blockchain than the others, than the original blockchain. So you just exploit that. You build a longer blockchain based on your power. So now you are on block 42, But the others, the public blockchain, they are just, the consensus is just reaching the block 41. This is the current status in the step 3. And then the step 4, this is what you actually hacking them. Broadcast the private blockchain, the longer blockchain that you are using. Broadcast it that to the network, and the others, based on the consensus algorithm, they will accept the longer chain. So when they see your blockchain, they will see, oh, maybe we should include this one and replace the original one. And that's what will happen. And then the private blockchain that you concave, that you build, become the new consensus blockchain managed by everyone. And then the original blockchain, this part of the blockchain will be abandoned. So this is what's happening. And when this happens, the transaction you excluded will not be included in the new blockchain. Hence, that transaction is reverted because it no longer exists. And the poor seller, it will just find out that they lose 100 blockchain and they lose the product. Oh my God, that's what's happening. So this is the concept of double spending in a POW based blockchain, taking Bitcoin as an example. So to be more specific, how are we going to do that? How can we do that? How should we build? Should we purchase many ASIC or to purchase many machines and build the office to do that? We don't. Nowadays we have Nice Cash. Nice Cash is a place who allows people to peer-to-peer purchasing hash power from the others to rent them for a period of time, and it's a marketplace of hash power in short. So what you have to do using the Nice Hash is to rent, is to find your sellers and pay them with Bitcoin and rent hash power from it. And what exactly you will have to do if you want to carry out this kind of attack, you should first create a mining pool. And you have to modify the post configuration, modify the node, the code of nodes to enable the functionalities, special functionalities, because you don't want it to behave normally like an ordinary node. You want the node to do something that you want it to do, right? So you have to trace the code, modify the code. You exclude to exclude a predefined transaction from adding it to a block. This is what you have to do. And then you will also have to let it to enable it to temporarily stop broadcasting the fork version of blockchain and temporarily hold it, and then it can broadcast it, and it's longer than the current blockchain or whatever you want it to broadcast. So after you do this, you point all the hash power you purchase to the mining pool you build, and then the nodes you purchase from Nice Hash, they will behave as you expected. You can guide them. You can have them do whatever you want. So this is the user interface from Nice Hash. And this is how you can purchase hashing power from Nice Hash. You can see the European market is a US market, and you can, when you press on the hash power marketplace and marketplace, you can see all the it's like an order book of hash power. And then you select the correct algorithm you want, because these different machines are maybe running different algorithms. So you have to choose the algorithm that you need, and use Bitcoin to pay all the purchase. This is what this marketplace only accepts. You can determine the duration and the amount This is an order form, and you can determine the price. You are a limit price, a limit hash power, the amount you're going to pay for. You can select your mining pool, and you can and choose the duration of the amount of duration and the amount of hashing power you want to purchase, and then just place purchase. So the introduction I was talking about is about the 15-1 attack, a normal attack. This kind of attack can be carried out to most of different chains that use POW as a consensus algorithm, like Ethereum and Classic, right? Recently, there's a huge big news. If you are not familiar with it, you can try to look on it on the internet, and that kind of attack can be used on most of the POW consensus algorithm. But here I'm going to introduce the second type of double spending attack, which is especially just for the Bitcoin SV. Before talking about that, I will have to talk about the more details about BSV. So first, BSV users believe that there's no need to wait for confirmation for a Bitcoin SV transaction. And why is that? Because they believe they can do the zero confirmation. So these claims about why zero confirmation is okay for BSV are all of these. And most important thing, my point of view, is that they believe that the propagation of transaction is very fast. And then the miner, they follow first seen safe rule. So namely, if a miner include one transaction with this input, and then later it's present another transaction with the same input, then the miner will consider that a false one, and then they just accept the first one. It's synced. So once they accept the transaction, they will not accept another one, trying to revert the first one or do something else malicious. So this is the first in safe rule, and then and that I consider the core concept is that even if someone managed to stop a spam through a confirmation, it can still be detected by having the receiver or the seller in our trading example. It's trivial by connecting to several nodes and wait for 5 seconds and try polling the nodes and let them know what transaction they have. And is there any transaction that with the same input but different in spending? If there is, they are conflicting to each other, and we know that somebody is doing some malicious action here, right? So this is what their claims. However, previously there's a researcher Razu. He did a demo to do this, what is so-called a zero confirmation double spend attack. What he actually did is he used a mobile phone. And spend his Bitcoin SV, and then when he sent a transaction, and he sent a transaction later, that revert the first one. So if you want to emulate, is that if a seller see this kind of stuff, he may give his products out, and then but with a reverted transaction, he will lose money. So this is why it's so-called zero confirmation double spending. And the core concept of it is to prevent the nodes from propagating a transaction between the miners and the other miners. So he connects to all the nodes of the network and send them the transaction simultaneously, whatever the number of the nodes are. just send them. And using the ratio of the two type of transaction, using the ratio of the minus number to determine which transaction should be valid at the end of the day. And in this scenario, it's the reverted one, right? Just revert the first one. And yeah, that's the core concept of doing that. So there's a suggestion of CSW, one of the big supporter for BSV, about this, about how to safely use BSV for everyone. First, it's based on what he claims is to, I think it's more like not a technical side suggestion. It's more like a business logic side suggestion on using BSV safely. And I'll explain a simplified version of the suggestion in the next page. So this is what he suggested is to use Bitcoin SV take it into a traditional trading workflow and use it like that. Instead of just sending out, instead of the example I gave you in the first few slides about the seller and trader, that workflow, he will consider that it's not safe. He suggests that everyone use this workflow instead. It's more like a traditional trading workflow. So talk about it. First, this kind of scenario, first we'll let the merchant create a transaction template. It's like an invoice. You send an invoice to the customer first, and then have the customer sign the transaction and hand it to merchant. And then the merchant will post the miners to check that there's no transaction with the same input currently on the network. No one knows about it. Then the merchant can then broadcast it to multiple miners at the same time. Broadcast the signed one, the signed transaction from the customer, broadcast it to the multiple miners at the same time. And after broadcasting it, the merchant miners to check if there's any conflicting transaction after that. So after 2 seconds, the merchant can hand over the product and he know he's safe. So what's the core concept? The core concept of it is that the merchant decides when and how to send the transaction and detect any transaction with the same input before and after he sent that transaction according miners. So in this way, the sellers, the attacker, would be hard for them to decide when to send their reverting transaction, like the former example, the hacking example. The core concept is that the merchant decides when and how to send the transaction, and that in that case, it can keep polling the miners to see if this buyer is trying to do anything malicious. So at last, in regard to this zero confirmation double spending attack on BSV, I would like to leave a last comment for this suggestion and for this attack and for this feature. I think people should understand any merchant who support the zero confirmation of BSV should also understand that they should implement the checking strategy suggested by CSW in that last page. Because if you don't, it might be a potential target of an attack. You should implement that checking strategy. So this is the reference, and that's all for today. Thank you everyone for listening. Thanks for your time. I'm open for questions. So you have to trust all miners. No, we don't have to trust all the miners. Just like holding different one. It's hard for all the miners to cheat you at the same time, right? So you just hold different miners, and if any one of them is trustworthy, you know you have the good ground truth. So did this attack happened before? Yes. The zero confirmation one happened before. By the researcher Razul. He actually demoed his attack and put it on the internet. There was a video. You can see it. Twice this week. Oh, Jay, what Jay is talking about is for Ethereum Classic. So twice a week. It is a 51% attack. BSV zero attack. A researcher demoed that, and have a video audio.